I bought this piece of HDPE off eBay, mainly because it's easier to obtain than Delrin or Acetal in the UK. And as it was square, I had to break out the 4-jaw chuck and reverse the jaws to grip it from the outside. Here I'm just showing that I transferred my measurements to my dividers. And I didn't dial it in, but used my tool on the tool post just to make sure it was fairly central to the chuck. Then I drilled a centre pilot hole and used my dividers to scribe the outer diameter. Then I ground up this trepanning tool out of a piece of broken parting off blade and mounted it in my parting blade tool holder. You'll note that the tip is slightly wider than the rest of the blade, and I also put a curve on the outer edge so it wouldn't chafe on the plastic as it was cutting. Then I set it up so that the curve of the cut would be on the outside of my scribe line. I've found that the thing to avoid is to let the tool heat up and start melting the plastic rather than cutting it. So I'm just pecking at it until I got down through the material and I could hear the blade just starting to tick 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 on the chuck jaws, and that left me with a thin skin that I could just cut with a knife after I'd taken it out of the chuck. Now I had a round piece to work with. I could put my 3-jaw back on with the exterior jaws to hold it on the outer edge. Here I'm transferring the internal radius to my dividers, and again using my dividers to scribe the inner diameter, and I only partially cut through this centre ring to give me a little more solidity so I didn't deform the part while I was gripping it. And as it is a tighter curve on the inner diameter, I've had to regrind my trepanning tool to take a little bit of the outer edge off. Then I ground up this broader trepanning tool so I could cut the channel, which went 10mm deep, leaving me about 5mm at the back for mounting the magnets. Once the channel was to depth, I could use my thin blade to complete the inner cut and leave myself with a machined ring. I had toyed with the idea of using a piece of plastic hose to make the lens out of, but in the end I went with polycarbonate just because I'd got some. If I were to do it again, I wouldn't use polycarbonate because, as you can see, it's a little bit chippy to work with, and I made this to be a tight push fit. And here you can see I'm milling the pockets for the magnets using a 9mm end mill. As you can see, it's not a centre cutting one, and I use my little mini rotary table to space out the pockets evenly around the circumference. And I went around again with a smaller end mill just to drill out that centre pip in each pocket. Then it was time to mix up a bit of 2-part epoxy and start putting in the magnets. They were 8mm by 2mm, and I had some of this LED strip left over from doing my under cabinet lighting in the kitchen. But I found that the sticky back, as I was concertinaing the strip to make it go round a circle, didn't stick very well, so I had to use some super glue. Once all the super glue was dry and the strip was well stuck in, I press fit the polycarbonate lens and used some polyweld to just glue it shut. Then I quickly hooked it up to my 12-volt supply just to give it a bench test. Then it was time to take it out to the shed and fit it. This is my overhead roof lighting alone, and this is an example of my existing side lighting. I was intending to use my solar panel supply for this ring light, but then decided to use the 12-volt supply off my control box. And I fitted an old audio jack just to make the whole setup more easily removable. These Christmas tree fixings are a push fit into the holes in the riser block, just to keep the cable tidy. And here's the last couple of views just to show you how it fits onto the flat face of the bottom of the vertical head, and the quill can come right down through it. Now that polycarbonate lens will protect the LED strip from any stray chips that might fly up into it. It looks worse on camera, but that shadow of the chuck in the middle doesn't really affect things because there's enough ambient scatter to light everything up really nicely.